Okay, so let's start. And yeah, yesterday we discussed few basics about the physical backups, how we can take offline backup, and in online backup we have seen how we can take physical backups, okay, online using low-level API backup and PG-based backup. We have seen few basics, and we also seen some log management. And today we are going to see about PG-based backup. Yesterday we already covered few of the basics, but still we will see how we can do um, backups and how we can do the restorations and how we can do point-in-time recovery. What are the different options we have in the PG-based backup? Okay, so as discussed, PG-based backup is, yeah, sorry, any questions?
Yeah, no. Sure. Looks like I'm the only one today so far.
Yeah, no problem. Because others will go recording because I have to cover in 1 hour practical as well. So that is the reason.
Okay.
Others
Okay,
will
go ahead.
No problem. Yeah.
No problem. Go ahead.
People will get no problem. Yeah.
Bye.
Yeah. And PG-based backup is an online backup. With the help of PG_base backup utility, we can take this base backup. Okay, this is online backup. We don't need to keep a database in backup mode, and again we have to copy nothing. So everything will be taken care by PG-based backup. So as a part of PG-based backup, our PG data folder is the exact copy of your PG data. Okay, that is part of your backup. Okay. So with the help of this PG-based backup, we can do point-in-time recovery as well as the restorations, and we can also use for replications. Okay, if you want to set up any replication, we can use this PG-based backup. So in the PG-based backup, we have a lot of options, even for replication. PG-based backup will also be used. And we don't need to keep the database in the backup mode. It will automatically keep the database in the backup mode. Okay, so we don't need to worry about it. And with the help of this PG-based backup, we cannot take a single database or a single table or single schema. Okay, we have to go with the entire cluster backup. It's not possible to take a single database or table. Okay. This is the syntax of how we can take a PG-based backup. So PG-based backup -d data direct. It is a backup directory. Okay. So basically, we have still so many options that we will see in practically what are the options available and what is the best way to take this PG-based backup. Okay. And this is the parameters that we have to set up for PG-based backup, because wall archiving should be enabled and continuous wall archiving should be enabled with the help of archive mode and archive command. And there is one more important parameter called wall_level. Okay, so wall_level by default it is minimal. We also have replica and logical. So what is this parameter basically? So wall_level parameter defines how much information it has to write to the wall files. Okay, so for standalone missions, for standalone servers, minimal value will be enough. Okay, if you are going to set up any replication, okay, maybe physical replication, okay, you may go on ahead and change from minimal to replica. And whereas if you want to do any logical replication, you can just set it to logical. Okay, so for standalone servers, minimal is more than enough to do any point-in-time recovery or recovery. This minimal is capable of writing the information to the wall files. So basically this parameter defines how much information it has to write to the wall files. Okay, minimal means it will write the minimal information, like it requires for point-in-time recovery or any restore recovery operations. This is enough for standalone. But if you have replication server, you have a primary and standby. If you set minimal, this is not needed. I mean, this information is not sufficient. Okay, minimal is not sufficient. You have to go with replica if you have any replication setup in place. Okay, and when you go with a logical replication, you have to use logical. Okay, basically for our standalone, minimal is sufficient. So we can set this wall_level to minimal. Why we need to set this parameter? If you want to do any point-in-time recovery or you want to do the entire disaster recovery in the same mission, okay, you can set this wall underscore level to minimal. And we have archive mode and archive command. Okay, archive mode we should be on, and archive command we have to point out the path where we have to copy the wall files to archives. Okay, so these two parameters to enable in archlog mode. Your entire cluster will be enabled in archlog mode. So here this is the syntax. Because we are using OS command copy, we're copying the wall files, %p is wall files to archlog files. That is the meaning of this. Okay. So your archlog will be exact copy of your wall files. Okay, it will be not in a different format. It will be same. Whatever the data having in the wall files, the same wall file will be copied to the archive. Okay, so that whatever the transactions which you are performing, first will write to the wall files, and from wall files, when the 16 MB size is full, then it will write to the archlog file. Okay, so these three parameters are mandatory. We need to enable wall level, archive mode, and archive command. If you want to do any point in time recoveries or restorations, these three are mandatory. Apart from these three, we also have, this three is enough for taking the backup. But when you want to do a restore, we also have the other parameters that we'll discuss. Okay. Now let's discuss about the point in time recovery. Okay. So point in time recovery is we have to restore or recover our entire cluster to a specific point of time, right? So basically in Postgres, we have a bunch of options to do this point in time recoveries. Okay, we'll see one by one. So for doing restore, okay, and recover, you should enable restore underscore command. Okay, this is archive underscore command. Okay, now we are doing restore underscore command. So restore underscore command, we have to specify, we have to copy from archives to wall files. This is reverse. Okay, whatever you are setting here we are telling copy from wall files to archives. Here we are telling copy from archives to wall files, because whenever you do any full recovery up to particular point of time, okay, you have to enable this parameter restore underscore command, and you have to start the cluster. So when you do restore underscore command, what it will do, from the backup, it will restore. After the backup, whatever the archives exist, those will be recovered from, those data will be recovered from this restore underscore command parameter. Okay, this is very important when we do any recover, full recover, not a point in time recovery. This is full recovery. We are doing with the restore underscore command. And to do a point in time recovery, we have different options. First parameter is, we have so many target options. Okay, the first parameter is recovery target. Okay, so this recovery target, we have only one value, which is immediate. So if you enable this parameter, what happens? Whenever it reaches the consistent state, okay, it will just open your cluster, which means, for example, you have the backup. After the backup, whenever it reaches any consistent state, okay, at that time only it will start the cluster, which means this is not a full recovery. This is just incomplete recovery, okay, or point in time recovery. Once after backup, whenever it reaches the consistent state, it will just open the cluster when you enable this parameter. Okay, along with this restore command, and also if you enable this parameter, it will just open after it reaches the consistent state. For example, after backup, you have like 10 or 20 archives. Okay, if it reaches consistent state after one archive applied, then it will open. Okay, so this option we don't usually, people will not prefer, because this is just, we don't have a specific time, we are not restoring a specific particular point of LSN number, we are not restoring a specific point of any timestamp. Okay, so this is just to recover to a consistent state, that's it. Now we have recover target LSN. Okay, this option also we have. So if you want to recover your entire cluster up to a particular specific LSN number, we have to specify that LSN number, so log sequence number. Okay, this is one more option we have. And we have recovery target name. Recovery target name is, it is like restore point, okay? In Oracle, we are going to create a guarantee restore point. We can able to roll back up to that restore point, right? By using flashback or some techniques, okay? We are going to restore up to that specific point of time. Here also same. We can create a particular restore point and restore point name, okay? And you can do your major activities later. And if something issue happen, you can able to restore and recover up to that specific point of time. You have to specify that guarantee restore point name here in this parameter, recovery target name equal to, whenever you are creating this restore point, whatever name you given, you have to just specify that name here so that your entire cluster will be recovered up to that specific point, that specific restore point. And we have recovery target time. Okay, if you want to recover your cluster up to specific time stamp, you have to specify that timestamp. Okay, for example, if any user dropped any table or major schema, okay, if before drop, you have to capture the timestamp from the alert log and you can able to recover up to that specific point of time. Okay, so this is point in time recovery with the timestamp. And we can also do point in time recovery with target XID. Okay, so XID is transaction ID. Basically in Postgres, it represents in two formats, right? One is the transaction ID, other is LSN. Okay, so we can use any of the representation, whether you can recover up to XID or LSN. So here you have to specify the up to this specific transaction ID I want to recover. Okay, so we have to capture the transaction IDs and we have to provide the transaction ID so that it will recover up to that particular transaction ID. Okay. And we have recovery target inclusive. Okay, this parameter basically whatever the targets which you have, which you specify. Okay, until this target is reached, this parameter will take care, and this is default on. Even if you not enable also, this will be by default on. So whenever your cluster reaches the consistent state based on the recovery options which you provide, it will take care of to recover up to that specific point of time. So even though if you enable or not enable, by default this is on. Okay, so we don't need to worry about this parameter. So this parameter will take care whatever the options which you provided, whatever the target options like target name or target time or target LSN, until that specific target reaches, okay, this parameter will take care to reach that target. Okay, by default this is on. We don't need to explicitly on this parameter. And one more parameter is recovery target timeline. Okay, so if you remember in the log management, okay, this is our wall file. So in the wall file, the first 8 characters represent the timeline, right? So whenever you do any restore recovery operations, your timeline will keep on change. So you are going from timeline 1 to timeline 2, timeline ID 1 to timeline ID 2, or you are jumping to other branch, from one branch to other branch. So for example, you are doing, so for example, if you see in this example, we have 11:45 and we are keep on doing transactions up to 12:10. Okay. Now we assume that some mistake happened. I want to recover my entire cluster to 12:05. Okay, here. What I will do, I will just stop the cluster and restore and recover up to 12:05 point of time. So then what happened? Your timeline will be changed to 2. Okay, now you are currently in 12:15, right? So this is our base backup. With the help of this base backup and on the top of this base backup, whatever the R case, we are going to do a recovery based on the timestamp. Now we are in a currently here. Now here what I thought to do, I want to recover again back to 12:15. Now we'll change to timeline 3, timeline ID 3 and so on. It's like we can say Oracle, we will do whenever you do a restore and recovery, incomplete recovery, you start your database with open reset log, similarly kind of thing. Here it will change the timelines from 1, 2, 3 whenever you do any restore and recover operations. Okay. So for example, you are currently in the timeline 10 and you want to go back to timeline 1. Okay. it is possible. You have to just specify here recovery target timeline to that specific timeline ID. For example, you want to go to the timeline ID 1. Okay, you have to specify that along with whatever the recovery target options which you used. Okay, so you have to specify that. But I think default it is the latest. Okay, it will do the list up to the latest timestamp whatever it has. Okay, so based on our requirement, if you want to go from one timeline to other timeline, you can specify this recovery target timeline parameter. So these are the multiple options for doing point in time recovery. Okay, so either one of the target option you have to specify. Either you want to go to recover with a timestamp, or either you want to go with recover with XID, or you want to go with the target name or with the LSN. So whatever option you want, you can just choose that option. Any questions while doing point in time recovery?
One question with reference to the timeline management where you changed the timeline 1, 2, 3, right?
Yes.
So when you are at 12:15 and you want to go back to, go back to 12:05.
Okay.
Then not 12:05. What is it? The timeline. Actually, you restored to 12:05 one time.
Yes.
After that, at 12:15, you want to restore to again 12:05, right?
Yes.
Or,
yes, again 12:05, because here I am in 12:30. I realized that some mistake happened. I record up to 12:15 again. So this is changed to timeline 3. Okay, so
so you recover up to 12:15. So
yes.
don't you need to take a full backup between 12:05 and 12:15 again?
No.
Or will the first backup will work?
Yeah, the first base backup would be sufficient. One backup is fine.
Okay.
On the top of this base backup, we need an archives. So
okay.
Yeah, that's is enough. So we don't need that another backup.
Additional.
Yes.
Okay.
So even practically we will see. Okay, we just take the one base backup and we'll see different options here. Okay.
So this whatever timeline ID is similar to incarnation in Oracle.
We cannot say like incarnation, but this is just it will change the timeline ID. So that's it. I mean, it will not start like again from. Yeah, we can say some kind of incarnation, but maybe we can assume the functionality will be same, but not exactly like Oracle. So we can assume that incarnation. So it is just like going to timeline 2 and timeline 3. So once you do the restore and recover when it comes to timeline 2, all the WAL files which is under the timeline 1 will be deleted, and it will create a file called history file. In the history file, it will make that up to the timeline 1, whatever the WAL files it has. Okay, it will make an entry in the history file so that whenever you do any restore and recover, it will be aware of based on that file and it will recover. Okay, so that we'll see practically to understand.
Okay.
Right? Yeah. So to do a point in time recovery, we have to use any one of the options. Either you have to go with recovery target name, recovery target time, XID, and we also have recovery target LSN or recovery target. Any one of the option we have to choose to do a point in time recovery. If you don't want to do point in time recovery, you have to do the complete recovery. You can just enable this parameter called restore command. That is enough. On the top of your backups, all the archives, whatever it generates, it will apply. Okay, so remaining options we don't need to enable. If we want to do a point in time recovery, then we have to choose any of the target option. Either you can go with the timestamp, you can go with the guarantee restore point name, you can go with XID, you can go with LSN, and so on. So now, for example, if I want to, let's say here in this example, I'm currently in the 12:30 and I went to 12:15. Now I want to go back to 12. Okay, so 12 is in the timeline 1, right, basically. And when I mentioned recovery target time to the 12 o'clock, and you also need to specify recovery target timeline to 1, because we are going to this particular timeline and until this time. So we have to enable two parameters. So here with this combination, we can enable two parameters. Based on the irrespective of your timeline, you have to choose this timeline ID along with your recovery target time. So when you are going to the previous timeline, you have to specify that ID. That's it. So yeah, so this is how we can do a point in time recovery with different options, different parameters. Okay. Now let's understand the steps, step by step, how we can do the point in time recovery. So if something happened, if any developer wants to bring back our entire cluster to a specific point of time, then we can stop the cluster and we can copy the files from the backup to the data directory. Okay. So previously all the files we can remove and we can copy from the backup folder to the PG data directory. Okay. And either we can remove the old files from the PG wall because as a part of taking backup, maybe you are taking maybe 5 years, maybe 5 hours back. Okay. So at that time we have old wall files, right? That wall files is not needed. We can just remove it. Even if it presents also no problem. Okay. We can just keep the wall files same. Okay. And then the important thing is you have to create recovery.signal file. Okay. So when you this is an empty file which you have to create under PG data. Okay. So when you create this file, a cluster will understand it has to recover up to a specific point of time where you, based on your parameter which you enable. Okay, either you want to go full recovery or point in time recovery, that based on the options whatever you have mentioned. So it will go and recover up to that specific point of time. So you have to create an empty file called recovery.signal in the data directory. Then only it will go to the recovery mode. Okay. So this is very important. And we can reject all the connections in the hpa.conf temporarily while doing the restore and record because no application connection should allow at that moment. So we are just rejecting the connections from hpa.conf and then we are going to start the cluster. Okay. So whatever the option which you choose, whether you are going with a point in time recovery or you are going to complete recovery, it will do the complete recovery based on the options which we have chosen. Okay. Sorry. So once the recovery done, okay, automatically your cluster will delete this recovery.signal. Okay, once the recovery consistent state is reached, this recovery signal will be deleted automatically. It will remove. Okay, we don't need to worry about it. So once the cluster is started and we are sure that all the data is came back up to that particular point of time, then we can allow the connections and we can allow these connections. So this is how we can do a point in time recovery. Okay, let's do practically so to understand better. Okay, so okay, so are you able to see both the putty sessions, right?
Yes.
Yeah.
One way. Yeah.
Only one we are seeing.
Only one. Okay, let me stop. Okay, so I have two putty sessions here. Okay. So my cluster is running on the 15 version and this is my PG data directory. Okay. And to take the base backup, we have PG_base backup --help. Okay, don't worry about low-level API backup. Low-level API backup, anyhow, we are going to discuss one example while doing the replication. Okay, so when we do a replication, at the time we are going to show you one demo how we can take a backup by using low-level API backup. Okay, so we have an option called PG_base backup, and we have multiple options. We can just do --help here to see all the options. So here we have a -d option or --pg data option to specify your backup directory. So in which directory you want to take the backup, we have to mention with -d. And we have format, okay, --format. So we have two options. One is a plain format, other is a tar format. Okay. So if it is a plain format, it is the exact copy of your PG data to the backup directory. If it is a tar, it will just zip into the tar file. Okay, so we have two options here, and preferable is T format because because whenever you have any customized table space, okay, when you are taking in a plain format, you have to specify that customized table space to be backed up in the separate backup directory. Okay, otherwise it will try to back up in the same table space location. Okay, so that's why we can go with the tar format. When you go with the tar format, it will automatically create the customized table space with separate OID. Okay, that we'll see one example how it will behave in the both formats when you have customized table space. Okay. And we have -R option whenever you want to take from remote mission. Okay, you can also mention the transfer rate of your data while taking the backup. Okay, so for this you need a network bandwidth again. Okay, and -R basically we use for whenever you want to set up a replication. Okay, at that time we will show you what is use of this R. So when you use this R, it will create automatically standby dot signal and so on. Okay, so this option basically we use while doing a replication setup. Okay, and this is important, table space map. Okay, when you are taking the backup with a plain format, when you have a customized table spaces, you have to specify your original table space location to the backup location. Okay, so you have to map it. So when you take the plain format, you have to make sure you have to map it. Okay, when you have customized table space. If you don't have customized table space, you don't need to use this option. Okay. Along with this, we have -X. This is very important. So this is the wall method. Okay, so you want to take the wall files as well as a part of your backup. So PG base backup, on the top of PG base backup, you are also taking the wall files backup. Okay, for this you have to use -X. None means it won't take any wall files. It will only take the data directory. That's it. It won't take the PG wall. If you do fetch, okay, it will take the wall files. Even stream also it will take the wall files. What is the difference between fetch and stream? So when you give fetch, so after your completion of your full backup, I mean PG data backup, it will start another session and it will take the wall files. Okay, when you give stream, parallelly, whenever you given the PG base backup command, so as a part of your full backup, when the backup is in progress, parallel it will start the other session and it will take your wall files, whatever the wall files it's generating while doing the backup, it will keep on taking. Okay, so either option will work. Okay, so it's good to use stream because your backup will complete a little bit fast because it's parallelly taking your wall files as well. And fetch is once your full backup done, then only it will start to take the wall files. Okay, either option we can use. And if you want to zip this backup into the compression, you can just use -Z. And we have different compression methods. Okay, default is ZZip method. And we also have some different algorithms like LZ4. Okay, this kind of algorithms we have. If you want, you can use that. So those are all like OS compression algorithms. Even GZ also OS compression algorithms. Okay, and this is also important. Okay, so -- checkpoint equal to fast. So whenever you start the PG base backup, it has to wait the checkpoint to be occurred. Okay, otherwise you have to wait 5 minutes to checkpoint. So if you just mention this option, it will forcefully do a checkpoint and it will start the backup. So your backup will start very quickly. So this option we can use. Okay, and this options is while creating the replications. Okay, we have a concept called replication slot. So you will understand better there in the replication classes. Okay, and one more important is progress. So if you want to check the progress of your backup, you can just use -P option. And again, this slot name is while doing the replication, we understand. Okay, and verbose. Okay, so this verbose will display all output internally what it is doing. It will log, okay, output. Even this option we have seen in the PG dump, right? And other options, don't worry, you will understand in the replication class, okay? And these are the connection options. If you want to take from remote machine, this PG based backup, you can specify that particular database or that particular connection string like host name, port, host, and so on, okay? This is the connection options. If it is a local, you don't need to specify the host name. If it is a different port, you have to mention the port number as well, okay? And username, password, anyhow we are giving. So these are the options we have. Before we take the full backup, let's try to understand few things. Okay. Okay. First, we need to enable our database cluster in the RKlog mode. So currently, we don't have cluster in RKlog mode. Okay, it is currently off, right? So let's go and enable the cluster in RKlog mode first. So before that, /home Postgres. I have a folder called org. Okay, this location I'm pointing as RKlog location. Okay, let me go to PG data. Let me go to my configuration file. First, let's enable the listener. So listener equal to star means it is allowing the remote connections basically. Otherwise, it will not allow any remote connections. So these are the two mandatory parameters which we are enabling. And apart from this, we also have archive command. Okay. So archive mode should be on and archive command. Okay. So archive command, we have to specify the path where we have to copy the archive log files. Okay. So here, what I'm doing, I'm just doing copy -i %p. So here they have given syntax. Okay. %p, and in which location you want to take the backup of your, not backup, in which location you want to store your archive logs. So I have a folder called /home Postgres and org. Let me verify what is the exact path. This is my path. Okay, let me copy and paste this path. %f. Okay, so we are telling to copy your wall files to arclog files. So whenever 16 MB is reached, then it will copy it. Okay, so these are the two parameters which we have to enable for enabling arclog mode. Okay, your cluster is now arclog mode. So it requires a restart because this parameter is a static parameter. So you need a cluster restart to affect these values. Okay, I'm just saving this file.
What is the %p and f? F is a format, right?
Yes, actually, that is archive format. Okay, this is wall. Okay, %p means you are telling to copy wall files to this location. So this is the default format, and you are specifying the path. Okay, so in this path you are telling to the arc background process to copy your wall files in this path. Okay,
Yeah.
in the same file name. Okay, so whatever the file name which you have in the wall file, it is the same file.
Okay. And you said it's after that 60% of this wall file full, then it will trigger the backup. And
16 MB whenever it reaches, because
sorry, 16. Okay.
yeah, whenever because wall file size is 16 MB. Whenever 16 MB is full, it will generate a new wall file. The old wall file will be copied to archive. Yeah. Okay, so before I restart, let me go and see. Okay, let me restart it. Now, if you go and see, show archive underscore mode, it is on show archive underscore command. Okay, this path is specified. Now, let's go and see whether archives has been generated. Because there is no transactions, it is not generated. So let's go and do a forceful log switch. Okay, select pg underscore switch. underscore wall. So this is the command to do forcefully log switch. Like in Oracle, we do alter system switch log file. This is a similar command. Okay. So when you do this, it will do a forceful log switch, and we can just go and see whether archives is coming. So I have did two switches, two archives has been generated in my archive folder, right? Now, okay, so if you want to know more information about your RK logs, okay, pgstat archiver, okay, or even you can use select start from pgstat archiver. Okay, so if you want to display in proper format, you can just use this. So this is like RK log list command in Oracle. Okay, you want to know your archives. Currently, we have 2 archives count, and this is the current last archive, and this is the time. Okay, it will give this information. Okay, there is no failed archive so far. Okay. Now, if you go to cdpg data, you have pg underscore wall folder. This is our Redlog files, right? So currently 3. Okay, still this is not reached 16 MB. That is the reason it is not right to the. So if you just do df and ss star, if you see each wall file size is 16 MB of size. Okay, so once the 16 MB is filled, then it will generate one more file. This is filled, it will generate one more file. Whenever the 16 MB is filled, it will write to the RK log files. Okay, and whenever it will keep on generating the 16 MB file until it reaches 1 GB. Okay, once the 1 GB is done, for example, you have so to become 1 GB, how many files it will generate? Basically 16, 16 and so on. Maybe some 20 files. Assume that it's a 20 or 15 files. So once the 1 GB is filled, again it will start from 1. It will overwrite in a sequential order. Okay. Now, if you want to know what is my current.
One question. I think we just did the switch log file, right? So
Yes.
by then, so much of transactions might not have happened. It just made it into 16 MB and then switched to the next level, right?
Yes, yes. Once it reaches 16 MB only, it will. But since I have done the force log switch, okay, it has switched to the multiple logs. But it will generate with a 16 MB of size. Okay.
Oh, okay.
Yeah. So now, if I want to know my current wall LSN, okay, so pg underscore current underscore wall underscore LSN. So this is my current wall LSN. This is like, we can say, logical representation it is showing. So if you want to know the full wall file, I can just use select pg underscore wall file name. So this is the current wall file. Okay, this is the physical representation. This is some logical representation. Okay, so if you write this in the pg wall file name, it will, if you just give the logical, it will give the full physical wall file name. So currently this is the current wall file which it is writing, right? So this is how you can find out current wall LSN. And if you want to know the full name of this logical representation, you can use this pg wall file name. Okay, and if you want to know what information it is writing in the wall file, okay, so we have a utility called, currently I'm in where pwd. Okay, so for example, if you want to know what information we have in the wall files, so basically even so you have so much anxiety, right, to see what data it has in the wall files. Even in Oracle, we don't get this opportunity to see, but in Postgres, you have a utility called pg wall dump. Okay, and if you just specify this wall file, it shows the information. Currently, there is no transactions. If we have transactions, okay, if you have any transactions, it will also show here insert statements, select statements, and so on. Okay, if you see here, it is having the LSN information and previous information, what it is having, and it also have the transaction IDs what is the oldest transaction ID and what is the current transaction ID and so on. It will make this kind of entries. Okay. So for example, let me go and write some data. Okay, I have employee table and currently I don't have any count on this table. Okay. So let me try to insert some records. So generate series is one of the function. I'm trying to insert almost 1 lakh of records, or I don't want even 1 lakh. I will just try to insert 100 records, okay, into this table. So currently I have 100 records in this table. So let's go and see. All fields is generated. Still it is 3. So let me go and see PG dump. You see here inserts, whatever I done the inserts, right? So it is giving all the insert statement here. Okay. So it gives all the redo changes. Whatever we are doing at the cluster level, everything will be logged in the wall file. Okay. So this is the LSN and this is the insert statement here. And this is the LSN, this is the insert statement. All these details will be seen with the help of PG dump, PG wall dump. Okay. So this is the utility as a part of your bindings you will get. Okay, with the help of this you can able to see what information it is writing in the wall files. Okay, now let's go and take the full base backup. I want to take my base backup in backup folder. I have a folder called backup and there is no data here. I'm going to take my PG base backup to this directory. Okay. And we have seen, okay, let me review hyphen help again. This is my backup directory where I want to take. Now, let me do with with Postgres user. So PG base backup -u Postgres user, and I want to take my backup into this directory. Okay. After this, I also want to take my wall files as a part of my backup. So which option I can use? -x. And I want to use streaming method. Okay, -s is the stream method, which means whenever you are taking the backup, parallelly, one more session will be connected and that session will take your all wall files, whatever it's generating during the backup. Okay, that will be taken. Now you also need to specify the format, right? So in which format you want to take. So I want to take in plain format or I want to take in the tar format. Okay, you have to specify. So for now I'm going with the plain format. Okay, -ft. ft is the plain format. Okay, now I want to check the progress. So to check the progress, I have -p, right? So this option we can use to check the backup of your progress. And now I want to check the output also. So I can just use -v, or you can use -, or you can use -progress instead of p, whatever option you are comfortable, you can do. Now I don't want to wait for checkpoint to be occurred. I want to forcefully do a checkpoint because otherwise checkpoint will occur every 5 minutes. Again, my backup has to wait for 5 minutes. I don't want that. So I can just use -, checkpoint equal to fast. So that it will do a forceful checkpoint and it will take the backup. So let me connect to other session and let's check the progress of the backup. Okay, so I have a view called, so let's start from PG progress base backup. So there is a view called PG stat progress _ base backup. Okay, so from this view, you can able to identify the progress of your backup. Okay, for now, I don't see any output because currently no backup is running. So I'm going to start the backup here. So PG base backup with this user in this directory, I'm taking the backup. I also want to take my wall files as a part of backup. So I given fxs and I'm taking with the plain format and progress and version. And I'm forcefully doing the checkpoint. Okay. Backup is going on. Let's backup is completed because it's very small database, right? So otherwise you could able to see here the progress, how much percentage of your backup is going on and how much data it has taken. For example, the total size is like 50 GB. So currently 10 GB is completed, 20 GB is completed. Like this, it will also show with the along with the respective of your size. Okay. And here, since we use -p option, it also displays the percentage, how much percentage it has completed. Okay. So currently we don't have any customized table spaces. Okay. So that customized table space part we will see in the next scenario. Okay. For now, we don't have any customized table space. Now I have taken the full backup. Okay. I have my full backup. If we go here, if you do ls minus ldr, this is exact copy of your PG data, right? So if you just go to $PG data, if you just do ls minus ldr, you have the same files. So whatever files we have, you also have the same files in the backup folder. Only extra thing is you will get the backup underscore label. So what is this backup underscore label file? So it has all the information which of the objects, which of the data files it has taken the backup. Those things we have in the backup label file. Okay. And you also have PG underscore wall folder, right? In PG underscore wall, it also creates one file called backup file, right? Which means up to 004, your backup is up to wall 4, your backup, as a part of your backup, wall 4 is there. So wall 5 is not there in your backup, which it will just give an entry here if you see. So start LSN. Okay, so up to here you have a backup and you could see the start time and end time. It also have the start time and end time, and currently it is timeline 1. Okay, if you see 0001 is the timeline 1 currently we have, right? And up to 4 it has taken the backup. Okay, 6 is just not generated. So 5 and 6 is not part of your backup. Okay, so let's generate few more archives.
So that means if you do some kind of point in time recovery, time recovery, so this will not come, right? So we can able to recover till 4.
Now up to 4 you have already in the backup.
Yeah.
Anyhow, you 5 and 6 will be pushed to archives, right? So that you can recover. So now what I'm trying to do, I'm still generating few more data. Okay, I'm just inserting some 1 billion records. So we'll see how many archives it generated. After the backup, I have done so many transactions. Okay, so we'll see.
Yeah, I understood, but this existing backup of this 4 means, so it's backup to the disk, right? So that's is it indicating that it's already backup to the disk?
So, yeah, it is indicating up to wall 4 you have backup. After 4 you don't have backup. You have archives. Okay, we'll see. Now I want to
adding to Suresh Southern, so we took the base backup, right? So that particular base backup time up to this wall 4 it is included. Okay.
Okay.
To recover, okay, to recover your database, maybe you want to recover for until the SCN, okay, or maybe the timestamp, okay. So based on the SCN or based on the timestamp you are preferring, okay, while you are restoring your database or recovering your database, this particular backup, including archeolog is already included in base backup, plus which option you are choosing and up to what time, okay, based on that the data will pick from either 5th or 6th archeolog, okay, based on your the requirement, which point of time you are going to recover, okay. So you will get the consistency data from here.
Understood. Okay.
Yeah.
Thank you.
Yeah. Now I have done some billion records transactions in this table. Okay, so now I have this many records in the table. And we'll go and see how many wall files it generated. See, it generated 5, 6, 7, 8, 9, A, B, C, and so on, up to 11. Okay. So these many archives has been generated after your backup. Okay, up to 4 you have as a part of your backup. Now, what happened? Now I will delete my entire cluster and I want to restore and recover up to the current timestamp, which means up to the wall 11. I want to recover. I want to get all my data back. Okay, how we can do that? So we'll see. So before this, we also have a folder called archive status. So what is the importance of this folder is whatever the archives which is already archived, it has that information. Okay. For example, your archives folder size is full. Okay. At that time, it cannot write, right? Your archive space is full and it cannot write actually.
Yes.
So at that moment, it will show like dot ready. Okay, it will not show dot done because that archive is still have to archive. Because of the storage issue, it is not able to write. That information you can able to see in the archive status. So there is a folder archive status in the PG wall where it will give all the information of your archives. Whatever it is archive, it will mark as done. Okay. So currently up to 10, your archives has been done. Okay, which if you go to the archive folder /home postgres org. So you could see up to 10, it is archived. Still, we also have 11. Okay, if you see here, we also have 11. Still, this is not filled 16 MB. So it is still waiting to be archived. Okay. Now, what happens? Now I want to do a complete recovery. Okay, how to do the complete recovery? I have taken a base backup. After the base backup, I have generated these many logs. Okay, these many logs having some billions of records. Okay, now suddenly my cluster is somehow crashed. Okay, I have just stopped my cluster and I'm just going to PG data directory and I'm going to do rm minus rf star, which means I have deleted all my data files, control files, all my wall files, nothing is there now. Okay, in my PG data directory. Okay, now I have a base backup /home postgres backup. So this is my base backup. I'm going to copy this all base backup into my PG data directory. Okay, this is the backup. So for in Postgres, we don't have any utility to restore. We have to use copy command to copy all our files to the PG data directory. Okay, this is called restoration. We are currently doing a restore. Okay, all the backups we are doing to copy to PG data directory. With a star, I'm copying everything to PG data. So if you go to PG data, now you could see all files is copied from the backup. Okay. Now we have the backup. After the backup, whatever the archives is generated, it has to automatically pick those archives and it has to apply. So for this, you have to add one parameter called. Okay, so we already have archive parameters, which we already added, right? Sorry, looks like I have opened wrong file, hp.conf. I have to open postgresql.conf. Okay. Okay, we have archive mode on. We have archive command. So if you come a little bit down, we have restore command. Okay, this is the one which we need to enable now because we need to do a recovery, right? So to do a recovery, we have to enable this parameter called restore command. In the restore command, just do copy. Okay, and you have to give opposite. So you have to copy from archive log files to this path. Okay, so you have to specify the archives where your archive location is there. Okay, so that this restore command will automatically recover all your transactions. Okay, whatever transactions happen after backup, it will recover all those transactions from this archives. Okay, so this is how you have to specify this. So this is opposite. First you are mentioning you have to copy wall files to this path, and now you are telling copy from wall archive logs to wall files. Okay, now you can just save this, and you have to do touch recovery.signal. Okay, So this is an empty file which you have to create. Then only your cluster will go to recovery mode. Okay. So I have just did touch recovery.signal. Now I can start my cluster. pg_ctl start -d $pg data. So before I enter this command, let me open the other session and let me open the alert log, what it's happening inside. We'll see. Okay. So now I'm just doing pgctl start -d pg data. Okay. So before you start, you have to make sure you have to create recovery.signal so that your cluster will go to recovery mode and it will apply all the transactions. And also in the in the PostgreSQL.conf, you have to add restore command, okay, to recover all the archives on the top of your backup. Okay, let me start and we'll see what happening. So now what it is doing, restoring all files. See, all the archives, whatever it is there, has restored. See if you see, restored log files 6, 7, 8, because these are all not part of your backup. After the backup, on the top of your backup, whatever the archives it's generated, everything has been restored. Okay, restored. All the things has been restored. Now, so this history file, you don't need to worry about this history file because this is something which is there in the arc location. This is something called, it will make an history file because the timeline is changed, right? From 1 to 2. Now, if you see the timeline will change. That is the reason it will look for the next timeline. Currently, we don't have timeline 2 files. So it will just, this is just a warning, we can skip. Now it is telling recovery complete. Database system is ready to accept the connections. Okay. Now your cluster is started. Let's connect to the database and verify the data of your employee table. So now your data has been recovered, right? Okay. Because while taking the backup, we have only 100 records. After the backup, we have inserted almost 1 billion records that all has been recovered from the archives like this. So this is how you have, this is complete recovery. Okay. Complete recovery means we are restoring up to the current time. All the transactions will come back as a part of your recovery. This is how you have to do the complete recovery. Now, let's do another scenario. So what I will do some more transactions, for example, /t. Maybe what I will do, I will try to create a guarantee restore point. Okay, for example, select short from pg_restore_point. This is like guarantee restore point. Okay, and I will just give restore point any name like Skyoops. Okay, this is my guarantee restore point name. Select pg restore point. And I will give any name of my guarantee restore point. So for example, let's say I'm doing some major activities. Okay. For example, I'm doing any major deployment in my cluster. Okay. So before that major activity, you can just create this guarantee restore point and you can just make this name in the recovery time. So again, you want to go back up to this particular point. So I have created guarantee restore point. After guarantee restore point, I have done some changes. For example, delete from employee where ID less than some 10,000 records or 1 lakh records. I'm going to delete from my table. Okay, now how many records I have? Select short from employee. Now I have this many records. Okay, now I realize that I have did some mistake. Okay, this many records has been deleted. Now I want to go back to up to this particular restore point. So if I go to this restore point, how many records I should get? This many records I should get, because at this moment, when I am taking the restore point, this many records I have. Now currently I have this many records, right? Now I want to recover my cluster up to this guarantee restore point. How we can do it? Okay, so let's assume I want to recover it. So I'm just stopping the cluster, and you can just go to the PG data. I'm just doing RM minus RF star. Okay, so before doing RM minus RF star, I want to show the PG underscore val. If you see, the timeline has been changed, right? So previously it was 0001, because since we did recently the complete recover, the timeline will change from 1 to 2. Okay, so all the files will be now timeline 2. Currently we are in the timeline 2. Okay, remember that point. Now we are going to remove all the files. Okay, I have removed all the files, and I have a base backup, and on the top of base backup I have arclog files. I don't need to worry about it. Now let's go to the backup, Postgres backup. These are all my backup pieces. I'm going to copy this all backup pieces to my PG data again. Now if you come to PG data, you have all files here. Okay, because I have copied everything from backup. Now let's go to the PostgreSQL.conf. Archive command.
One question.
Yes.
Why do you need to copy manually when you say restore E?
Because we don't have any separate utility to restore. We have to copy from the backup. So this is how we do in the Postgres. So restoring.
Okay, go.
Yeah, restoring means we are copying. That's it.
Yeah. So this is the only method for irrespective of any scenario, right?
Any scenario, the same. Yeah. Only thing is the parameters will change. That's it.
Understood. Yeah.
Okay. Got it.
Okay. Now I want to enable the restore command. So restore command is copy from this location. I want to pick my arclog files. Okay. Along with this, we also have some recovery targets, right? As we discussed in the slides. Now I want to use restore point name, right? Because I want to restore up to the specific restore point name. The restore point name is Kairos. Let me enable this parameter. The recovery target name. If you want to restore to a specific timestamp, you have to give time. Or if you want to recover a specific LSN number, you can do it with a LSN. Okay. For now, in this scenario, I'm using this restore point name. Okay. So let me save this file. And before I start my cluster, as usual, we have to create recovery.
So what is the importance of this recovery.signal?
Whenever you start the cluster, Postmaster will check, is there any recovery.signal file here? If it doesn't have any file, then it will start the cluster. It won't do any recovery operations. So if you want to change your cluster into recovery mode, you have to use this recovery.signal. This is very important.
But this file is it's not containing any information, right?
Yeah,
it's an empty file you created.
It is just giving hint to the cluster that you have to start in the recovery mode. Apart from this, nothing. So because cluster will understand that it has to go to recovery mode. Apart from this, nothing. So this is just to identify to go to the recovery mode, we have to create it. So apart from this, nothing much we have to worry about it. Okay, so
basically, once you complete the restore, you would need to change the Postgres.conf for all those restore commands that you enabled. You need to change them back, right? Revert them or comment them out.
Yeah, because maybe in real time you have done a incomplete recovery, okay, and later point of time you have to, after you do incomplete recovery, once the cluster is start, you have to comment it. Otherwise, next time when you start the cluster, again it will treat that. But anyhow, but anyhow we are not creating recovery.signal until unless we create this signal, it won't go to recovery mode again. Even though if you have that parameters, no problem, but it's good practice to disable that parameters again. Maybe by mistake, if someone do recovery.signal, okay, your entire cluster will go up to that specific point of time. Then all your data is gone. So that is the reason it's good practice. You can remove those restore and recovery target options after you recover your transactions. Yeah.
Otherwise, if people forget to disable it, so then it's required again downtime for the cluster.
Yes. Until unless we are not creating this file, it won't go to recovery mode. It will directly start. But again, we don't know. Maybe a few times. Okay, so if people may create this, again, it may create problem. So that is the reason it's good practice to disable that parameters. Okay. So I've created recovery.signal and I'm going to log file. Let me open the log file. Okay, so I'm going to start the cluster here. Okay, so let's monitor the log file. Now, completed backup recovery to LSN. It is recovering all the transactions. And now, the recovery is stopping at this particular restore point. Okay. And now what it is telling? It is telling you have to resume your cluster by running this utility. Okay. You have to promote your cluster. So whenever you do any point in time recovery, your cluster will be still in recovery mode. Okay, it won't allow any connections. It will only allow read-only connections. If you see, database system is ready to accept read-only connections. It will not allow any read-write connections until you run this command. Okay, this is only whenever you are doing point-in-time recovery. When you do full recovery, you don't need to change this cluster again. You don't need to promote. Whenever you are doing any point-in-time recovery, it will only allow read-only connections initially. After you verify your data, okay, now I'm just connecting to P-SQL. I'm connecting to my database. And let me check the count of my count is back now, right? Here, if you see my count is after my restore point, this many changes I did. Everything is gone now. I can able to restore up to this specific point of time. Okay. So up to this specific point of time, what data I have everything I have here, right? So it has recovered. Now it won't allow any read-write connections now. So it will only allow read-only connections. To convert into read-write, you have to run this utility, whatever it is giving hint in the alert log. Okay, you can just run this function, pg vol replay resume. Okay, once you run this command, what it is telling? So database system is ready to accept connections now. Okay, and end of recovery is done. Okay, so this is how you have to do the point in time recovery based on a specific restore point. Okay, so it has recovered until this particular restore point. So if you observe one thing, this is the timeline 1, right? So all these files are timeline 1, and you also have the timeline 2 file. It automatically able to detect it has automatically picking the timeline 2 as well, okay, from the archives. So we don't need to worry about it, because internally it creates, for example, if you go to /home postgres.org, it is creating some history file, right? So from this history file, it able to identify, okay, up to which particular point of time you have, we have done. Okay, for example, in the first recovery, you see we haven't mentioned any target. We have applied full recovery, right? In the second time, we applied restore point, right? So it is marking here. So based on that, it can identify and it can go and pick all the files even in the next timeline as well. Okay. So this is one scenario. Now let's do a timestamp quickly. How we can do a point in time recovery with the timestamp. Okay. So for example, current time is select now. This is like select sys date in Oracle. Okay. I'm just making a time here. Okay. After this time, let me do some changes. For example, let me do delete from employee. I've deleted all records from this employee. Now I don't have any records in this table. Now I realize that someone developer has deleted by mistake. I want to bring back this all data. Okay, after this particular specific point of time, I want to recover. Okay, even you can able to identify the times, because when you enable logging, even the delete statements will also log into the alert log. So you can capture the timestamp there as well. Okay, before delete, what is the timestamp, you can capture that as well. Okay. Now I want to recover my cluster until this specific point of time by using recovery target time option. So as usual, let me stop the cluster. Let me go to PG data. Let me do another session because here we have timestamp. Again, it will go. Okay, so PG data. And let me remove all the files. So let's copy from the backup. And you can just go to PG data and you can open the postgresql.conf. Let's see what happened. Okay, so let's open the postgresql.conf. Just come to archival parameters is already enabled, and let's go and enable these parameters. So why this parameters is always disabled? Because when we are taking the backup, this parameters is commented. So we copied all the files when we are taking the backup. That is the reason here. This options is we have to enable it.
So after recovery, it's automatically gets disabled, right? I mean, it's getting enabled.
No, it will be enabled only because we copied from backup, right? At that time when we are taking the backup, this is commented at that moment. So that is the reason we are getting the same file, right? So okay, restore command we did. Now we have to enable recovery target time. Yeah, so let's capture the timestamp from the other session. I want to recover until this specific point of time. Okay, and let's save it, and as usual create recovery.signal. Okay, so I have recovery.signal file here. So once you start the recovery, okay, so this will be automatically deleted. Recovery.signal will be automatically deleted. So let's go to the log and just open the alert log. And now let me start the cluster back. So it is recovering, and it is recovering even third timeline, and recovery has been stopped until this particular timestamp, because this is the timestamp which we provided, right? So until this timestamp, it will recover and it will stop. And as usual, it will accept only read-only connections, and we have to replay this. Okay, so let's go here and so I got my data, everything back, even I deleted. Until that specific point of time, I have recovered my cluster. And once you verified your data, you can just resume your connections back. Okay, so now your database is ready to accept the connections. Okay, this is how you have to do a point in time recovery with the different options. Similarly, you can also do with LSN. Okay, so for example, you do some any changes, and you can just capture the current LSN. Okay, so what is the current LSN? Based on that, you can just pg underscore current underscore wall LSN. Okay, So you can capture this, and until this particular point, LSN also you can do a recover. After you capture this, you do some changes, some creation of table and delete it, and you can just do until this particular point of time LSN. But at that time, you have to enable this parameter, right? Corner. You have to enable this LSN. Here you have to specify that LSN which we captured. Okay, this LSN value. So like this you can do, or you can try this option, and even you can capture the transaction ID, what is the current transaction ID, and even you can do up to that particular point. And an important thing is, once you do everything, you can just comment these parameters, because it's always good to practice to comment these parameters. Okay, even this restore command. Okay, and you can just save. And whenever you do next time restart, these parameters will affect automatically. Okay, so you can just disable and keep those parameters once you do a point in time recovery. That's a good practice. Okay. Yeah, so that's it I have for today. Probably tomorrow we'll see a few more scenarios along with the PG backrest. Okay, so there is one more open source tool called PG backrest, where you have more options there. So we'll see that. You have any questions so far? So we'll share the lab manual. Please try to practice this all scenarios.
Yeah.
Probably Monday, because you have 2 days time, Saturday and Sunday, you try to practice it. Probably Monday we'll come back with a PG backrest along with a few scenarios. Okay.
Okay. So this flashback, if you can enable in Oracle, so that will create some logs and that will impacting some space related, right? So do we have such kind of same mechanism here?
No, because this is not like, we don't have flashback option in Postgres. It is like restore point means it is just internally it is just using the timestamp only. So it will take a snapshot until that particular timestamp, and it will recover. So it won't generate much archives. Like we are not enabling flashback options, such kind of things we don't have in Postgres.
Okay, so even if you can, for example, if you have more than 4 to 5 clusters, so if I enable this option, so it doesn't make any impact on
the cluster. It won't generate any extra archives. As usual, how it is generating, it will generate similarly, because this is just it is internally keeping a snapshot. That's it. It is not like creating separate flashback logs and it is applying from there. Nothing. It is applying from the general RK log files only. So it won't be any burden if you enable this restore point.
Okay. Okay. So do we have an option to identify, like, each cluster, how much space it was consuming, something like that?
Yeah, we have an option, like we can check the
data usage or
database size, okay, and the cluster. All the database sizes you have to just submit, okay. So that will provide in the lab manual how to capture the size of schema, how to capture the size of databases, okay. So the union command, you can just capture all the databases, or simply you can just do /l plus. It will also give the sizes of your databases, how much size it consumed. For example, in this case, 134 MB, and these are the databases. It will be very less. Even with the commands, you can able to identify the sizes as well.
Okay.
And as usual, you have to monitor the disk size as well with the help of df-h, because your OS, all the table spaces are in the file system level, right? So you have to monitor that file system as well. Okay, so that's it I have for today. If you don't have any other questions, we can close today and we can regroup on Monday. Okay.
Thank you.
Okay then. Thank you. Have a nice day. Bye.